the HAWE Tech Podcast.
Hello together, my name is Markus. I am Key Market Manager for Mobile Machines. And today we want to talk about the topic, do you know that variable displacement pumps also provides benefits for electrified vehicles? As a guest I have here Tobias. He is Product Manager for the Axial Piston Pumps and will help me through this topic.
Hello Markus.
Hello Tobias. So first question, what is the main difference between fixed displacement pump and variable displacement pump?
Fixed displacement pumps have a constant geometric displacement. That means if you run a fixed displacement 100 cc pump with 1000 RPM, it creates a flow rate of 100 liter per minute, if we ignore the volumetric efficiency in this simple example. On the other hand, a variable displacement pump can adjust the geometric displacement depending on what you need at specific operating points in an application. That means a 100 cc variable displacement pump running at 1000 RPM can give you any flow rate between 0 and 100 liter per minute. So here you are much more flexible.
Okay, and when do I use which pump? In which application do I use which pump?
So fixed displacement pumps are often used in applications with relatively short operating times where the costs are very important. Typically examples here are tipper trucks they are often only used 2 or 3 times per day maybe, or aerial working platforms, simple aerial working platforms, small loader cranes. Here the costs are very important. They also often use fixed displacement pumps. On the other hand, variable displacement pumps are used in machines with relatively long and high operating times, where not so much the costs, but more the energy efficiency and the energy consumption is in the foreground and in the focus. If you think of rotary drilling rigs or tunnel boring machines, large excavators, large agriculture or forestry machines, here we often see the variable pumps.
Okay, energy efficiency is a good keyword. With the electrified machines, what we see more and more in the market now, efficiency becomes more and more important. Before with combustion engines, to be honest, nobody really takes care about it. Mm-hmm. But today now you can really calculate the cost of the batteries, of the inverter, of the complete equipment you add to an electrified machine. So I think there's a complete new idea to look more into efficient solution. And what do we have as an approach here?
HAWE offers a modular system of various different electric motors, including frequency converters and matching hydraulic pumps. For smaller power demands, we normally use fixed displacement pumps. For larger power demands, we recommend to use variable displacement pumps.
Okay, why do you think so? Because with an electric machine, I have frequency control, so I can change the turning speed. Together with a fixed displacement pump, now I have a unit which can generate each flow, like before a variable displacement pump. So why do I need the variable displacement pump still?
Yes, that's right, Markus. So in principle, with a variable speed drive, in combination with a fixed displacement pump, you can create a variable flow rate, as you said. That's correct. However, such a system has some limitations. This is something we learned at multiple customers in various different applications. Because normally if you design such a system, you have to design it in a way that you reach the maximum flow rate requirement of the application. Now, if you use a very small fixed displacement pump, you automatically need high rotation speeds. High rotation speeds also means you have a high noise level, and a high noise level is not accepted by the customer because especially in electrified mobile machines where you don't have the combustion engine in the foreground, here the hydraulic system is much more in the focus, and you have to keep the noise level as low as possible. So if we can't work with the rotation speed, we have to use a large pump with a higher geometric displacement. And this also, if we use a fixed displacement pump, this also means we need a large electric motor and a large frequency converter. Because in such a system, the drive torque of the electric motor is the limiting factor. And if you use a large electric motor and frequency converter, the system gets very expensive. The volume will be high and also the weight will be high. And this is not an ideal solution, of course.
Yeah, you're right, of course. You said with a big pump, you also need a big motor. Is it due to the torque? Is the torque the limiting factor? And
yes.
If so, what is the reason, or what is the torque for the hydraulic pump? So how is it calculated? Let me say like this.
The torque of a hydraulic pump is equal to the product of its geometric displacement and its pressure. And with a fixed displacement, we cannot adjust the geometric displacement, so we always need the maximum drive torque from the motor depending on that displacement. Also, the pressure is not adjustable because it is a parameter that we get from our customer. So with the fixed displacement pump, you need a very large electric motor. With a variable displacement pump, I can adjust the displacement and thus realize high pressures at small flow rate or high flow rates at small pressures.
Okay, that's interesting. So that means that the variable displacement pump still have its advantages, but you have to adjust these situations. How do we do this?
You can limit the torque that the hydraulic pump needs and takes from the electric motor by using a simple mechanical power controller.
Okay, but then I have a question, because the electric motors, you can boost them, so you can over torque them in a short period. So mechanical power torque controller or power controller is only one setting. Do we have also a solution which can handle with this?
Yeah, absolutely. We also have a solution for that. Besides the mechanical power controller, we also have an electroproportional power controller. And with that one, you can adjust the torque and limit it to any value that you need. And therefore, we can realize the nominal torque of the motor, the electric motor, and also the peak torque.
Okay, interesting. So thanks to the power controller, we can now use smaller electric motor, smaller frequency converter, and due to the variable displacement pump, we can drive this unit with lower speeds. Mm-hmm. So you mentioned before the speed is also important for the noise level. Do we have there some figures?
Yeah, so if you reduce the rotation speed from 2000 RPM to 1500 RPM, you will reduce the noise level by 5 decibel. So that's a lot, roughly half the value or even less than half of it.
That's something you really hear on the machine. That's really a big difference. Okay, thanks. Then, to sum up, so in terms of energy efficiency and noise, and also the matching of small components, small motor with pump and converter, the variable displacement pump has still its advantages, and I guess also a future in electric mobile machinery.
I think so too, yeah. The variable displacement pumps will rather increase in regard to their importance in the future with the electric machines.
Okay, thanks for the talk and the interesting information. If you have some ideas or topics for the next podcast, please write us on the podcast@hawe.de.